What if space was not a vacuum, and in fact was full of air?
So I kind of followed on from the question of, is the planet going to fall into the sun? Which, yes, it would eventually happen, but yes, it would take a decent amount of time. But beyond that point, I started thinking about, we frequently destroy the planet. We rarely go bigger than that. So let's see just how much this actually messes up just, the universe in general. So yeah, so over time, eventually the planet and just everything orbiting our sun will fall into the sun. But a fun fact about our sun is that it actually orbits the center of the Milky Way galaxy.
Oh no.
So that it's a pretty big orbit. The average velocity is 828,000 kilometers an hour, so pretty fast. And currently it takes about 230 million years to complete an orbit. So it wouldn't happen once again anytime soon. But much like we would eventually crash into the sun, eventually the Milky Way galaxy would just condense to the middle. And fun fact, you might be asking yourself, well, I wonder if the Milky Way galaxy orbits anything. Turns out, it doesn't actually orbit. It actually orbits an arbitrary point in space. But that point is the center of gravity between our galaxy and the Andromeda galaxy, which just spin around each other. And actually, fun fact on this one, they will actually collide in about 3 or 4 billion years, just as things stand now in our actual universe. So we're gonna speed that up a little bit more, I think, probably.
Or slow it down?
I'm actually not 100% sure. But sort of the point I'm getting at here is that the way that the universe works, everything is spinning around something, and all of those somethings are going to condense in the middle. Except, fun thing, that's actually not true, as fun as that idea is. Because you see, space is really big. Really big. I feel like we talk about how big the ocean is a lot. We actually haven't talked about how big space is all that much. Space is really big, guys.
Are you saying space is bigger than the ocean?
Space is actually bigger than the ocean.
I don't believe you, Ben.
I know. It's
hard to believe.
It is a tough thing to think about there. But space is quite big. And the problem we have now is that all of that space, that's just big empty space right now, is full of air. And air, as you probably are aware of, itself has mass. And there's so much space in space that the mass of all the air that space now is actually drastically more than the mass of basically everything else in the universe. So what actually is going to happen when all of the vacuum of space is replaced by space air is that space air is going to basically the effect of all of that air, the gravitational effect of it is going to so drastically overwhelm the gravitational effect of everything else in the universe that it will effectively be pointless. Basically, everything is going to be where it is and just be pulled in every direction by air because there's so much of it.
There's too much air.
So orbits kind of stop, it turns out, actually. I don't know, so I'm not actually sure exactly how this happens mechanically. I'm assuming, they won't just stop immediately because momentum, but eventually things will hit a stasis where everything is sort of just suspended. Which probably isn't going to be good for literally anything. But that's actually still, somehow, not our biggest problem in this situation.
How much bigger are we going to get?
Well, so we got all this air that, as we've mentioned, has a lot of mass. That's just kind of out there. And I sort of just to think about it. Think about when you have, if you spill some liquid on a flat surface. It doesn't just sort of, stay spread out. It sort of beads up into little domes, or sort of similarly, in all the shots of astronauts up in the space station, they'll do that trick where they get out a bag of water and open it up, and the water floats out,
little bubbles,
makes little bubbles. Yeah, so that's sort of just what in this situation what a fluid will do, which air is a fluid. So as all this air is just out in the formerly empty vacuum of space, it's going to start forming little bubbles, basically, where the air is going to sort of start condensing around each other. And as that happens, as it starts condensing into these little, orbs, of air, it's going to start having a higher gravitational force and going to start pulling more air in. And that's going to keep happening until eventually that air is going to get dense enough that it's going to become so highly pressurized and so hot because of how pressurized it is, that it's going to ignite and basically become stars. All of this air is going to start turning into stars. But then, because there's still so much air around, because space is really big, guys, it's still going to keep pulling air in once it stars, and it's going to keep getting more and more massive. And eventually, what this is going to lead to is all of those stars are going to collapse and become black holes. So, the one thing I'm not 100% sure of is, and because there was zero way to actually figure out exactly how this would go down, because obviously there's no way I can do equations for this. So there's two possibilities, and I think so. The first one is that everything condenses at the center of the universe, but I don't think that happens. I think that the universe is big enough that it would be too slow for that process, that the black holes are going to start forming before that. So I think the end result of the universe in this situation is basically that pretty much evenly spread out throughout the universe are just countless new black holes that just basically start pulling in everything, which is pretty much as final as we're going to get, I think. That is our biggest problem. I do not have a bigger problem than that one.
Hey, Ben, can I hit you with a science fact?
Sure.
Black holes can eat other black holes.
This is true. So I guess that is the end game, is that these black holes become this terrifying Ouroboros of black holes eating each other, and man, I don't know what's going to happen at that point, because I don't think anyone knows what would happen at that point, but it can't be good.
Matthew McConaughey will fly through it and see his past self and then change a thing
He'll
on
just
his...
see Matt Damon growing potatoes on the other side.
on Mars.
Yeah. He's still on Mars.
So that's kind of the end point of mine, is black holes destroy the universe. So that might be a new, I was going to say new low, but I think it's a new high for us. It's like the high score.
I would say so. It's an accomplishment.
Yeah.
High score, guys. High fucking score.
Yep.